Today you're doing the EKG lab using the Pasco GLX. The first thing you're going to do is connect all of your equipment before turning it on. So you're going to use your USB cable to connect that to your GLX. You'll attach this to the back of your printer. It'll only go in one direction. There we go. Your printer, you'll just open this up and put your paper in the top here. Okay, now your printer's on. This is your EKG probe that you'll be using. Flat side, it goes on top. Of course, your directions are on top. This is the top of your data collector. So you'll put that right into this port here. Okay, so with that collected, we will go ahead and turn our unit on. And it will probably take a little while to initialize, so let's be reading the directions about where your electrodes attach. The green electrode will go on the right bend of your arm, and the red one will go on the left bend of your arm, and the black one will go on your right wrist. Okay, and so let's go ahead and get set up here. You're going to use these electrode patches and have the person who's getting their EKG taken to sit down and relax, and you'll put, well, pardon me, you'll put one of these on the left bend of your arm, the right bend of your arm, and on your right wrist. Okay, and then you may need to look back at your directions. I know I'm needing to, just keep it straight. The left bend of your arm is red. Okay, the black is going to be your right wrist, and the green will be the right bend of your arm. Okay, at this time you'll have your person to kind of put their arms in their lap and relax, and then you'll have another person in the group to push collect on your data collector and run the experiment for just maybe 3 seconds or so. So we'll go ahead and do that now. And good. And go ahead and let's hit collect one more time just to let your person get used to this process. Okay, good. Now, what we're going to do, guys, now is I'm going to remove these, and we're going to look at how to analyze our data. So let's take a closer look at our data screen here. Down at the bottom it's seconds, and this is millivolts. Guys, we're going to scale our graph. So we're going to hit F2 for scale, and we're going to stretch it out so that you can see your points a little better. This is every half second. If you stretch one more time, that's it looks like that's every half second as well. This looks a little more favorable to me, so we're going to work with it here. Let's also stretch it up so that we can identify our points a little better. So that looks nice. Okay. Alright, so you work with that scale until it makes you happy. Okay, next thing we're going to do is we're going to come over here to graph, and you're going to select data cursor, okay, so that you can scroll along your graph with the data points. Okay, let's see, I don't see where that's showing up for me. Let me just try that again. Yeah, okay, so it went down to connected lines, so let's go up, data cursor, and there's the little button that allows you to scroll along your line. So what we're going to do is we're going to back ourselves up. This one, this particular cardiac cycle right here looks really nice to me. I can definitely notice my P, Q, R, S, and T. So what we're going to do is we're going to grab and see what the data is here. So we're going to scoot over until we get to that highest point, and that's our P. Alright, I believe that's it. Yes, so back up. Now you're going to come over here to Tools. Tools, and you're going to select the Delta tool. The Delta tool will allow you to tell the difference between your data points. Okay, so as we back up here and we go back to that point we liked, Okay. Alright, so that's our starting point, so it's showing 0, okay, and 0 time. What we're going to do is we're going to come over from P to Q, so P, Q, P, Q, R. So we need to know the PR interval. So we're going to scroll over until we get to our R, which will be way up high. That's the highest point there. So the difference between P and R, as you can see, is 0.489. Okay? And then, so that will go here, PR interval. And then you'll also have to collect your QRS and your QT. Okay, so this is your R. So if you'll come back to your Q, which is your lowest point, I went all the way to the end, which is the lowest point before you hit that spike. You know what, I just hit enter by mistake. So let's come back and grab that tool again. Tools, delta, okay, and grab our data cursor. Okay, here we go, there's our P, and then you'll come over here until you find that lowest point before you go up to R, and I think we're at it. Okay, so now we need to select that delta tool, and we're at 0, so now we'll go up, 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 and okay, so from Q to R is 0.74, and then we'll come over and down until you get to your S, and that is 0.205. So from Q, R, and S you had 0.205, and then if you keep going all the way to T, that will be your QT, and T of course is going to be that giant peak there. Okay, so you'll come over, over, over until you get to that T, and there it is, and that's 0.445. You know what, I'm telling you guys millivolts this whole time, and pardon me, I'm supposed to be telling you seconds. We're timing how long it takes to get from one point to the other, and I was looking over here, I guess because I kept seeing it change really well, but you're supposed to be recording how long it takes. I was thinking my values are way off. So actually 0.3 is just about normal for QT, so that is good news for me, because I was thinking that I was all messed up. Let's look at how to print our graph. You're going to come to F4 under Graph and scroll down to Print. And you will get an error message here, so we're going to work with this. If you will, press F4 for PCL, and then if you will, come over here and press F4 again. Okay, at this point I believe if you'll press F1 and print, your printer should work. Okay, yes. I have a graph that I printed for you. Another way to approach waiting to hear that printer turn on. Another way to approach this data analysis to me is a little simpler. Here's your time in seconds. And so notice from 1 second to 2 seconds, you have 41 millimeters. Okay? Well, if you label this graph at P, Q, R, S, T, guys, a really easy approach would be to diagram your P to your R and measure that distance. So from P to R is about almost 4 millimeters. So if you say 4 divided by 41, because that was the total millimeters in 1 second, you get 0.09. So your PR interval was 0.09. And your QRS would basically be from here up, down, so from here to here. And measuring over there, you get 1, 2, 3, about 3 millimeters. So 3 divided by 41 is 0.07. And finally, your QT interval would be PQ from here to here. So what you could do is bring this peak down and measure in millimeters from your Q. Oh, a minute, here's your Q. PQ. Measure from your Q to your T, and that would be, that's 10 millimeters, 11, 12, 13 millimeters. So 13 millimeters divided by 41 is 0.31, which, if you remember, is the same value we got by running the delta tool up here. So, you know, I think with all that being said, we were actually a little quicker by analyzing our data with measuring with a ruler and calculator.